Good morning. Welcome to the audience. Today, I am going to give a lecture in the course of Structures on Expansive Soil. The course code is Bce078. The topic on which I am going to talk is about the moisture equilibrium and soil structure. Moisture equilibrium means it's a water, and soil by itself we should give a definition. Then moisture equilibrium will explain. Then soil will explain. Soil structure we will explain. Moisture as such, if you look at it, it is water, H2O. The chemically it is called as hydrogen and oxygen molecules. And the structure of this molecular status of the water is one oxygen atom, two hydrogen atoms. So each H2O is bonded to its nearest neighbor. If you look at it, the the bonding of the water, it is closely compact and then very tightly held in the status of solid when it is in the state of ice. When some energy is given to that, this bonding be getting weaker and it flows like a liquid because of the bonding interactions in between them, it is losing because of the high energy. When you have more energy is given to that, then it reaches the state of vapor, and that is called the gaseous state where the molecules are independently moving, and that is called the vapor state. And you can have the status like that. When you coming to the soil structure, the soil we should define first. Soil is the geological definition wise loose surface of the earth distinguished from solid bedrock. It is not a bedrock, that's all. The traditional definition is material which nourishes and supports growing plants. That's about the soil on the agricultural area. Component definition is it is a mixture of minerals, matter, organic materials. That's a component definition. The portion of landscape, a collection of natural bodies occupying portion of the earth's surface, and other things integrated effect of climatic changes, disintegrated part of the earth. These are all the other definitions on the landscape area. So soil structure, if you see, the soil is available on the landscape. If you take it, you just take a small area in the landscape of very specified area. Then if you take a sample of that, pattern of that, then you can see the soil will comprises of very hard material at the bottom, then very hard soil at the bottom. Then you have moderately soil at the intermediate level. Then you have loose soil, then a loose vegetation on that. Some of the roots of these vegetations can go up to the hot state of the soil. Sometimes it penetrates into the rock also. If any disturbance is given to the soil as shown in the figure 3, it just fails or sometimes it gets displaced also. That is the character of the soil. So the soil as such, if you look at the slice of the soil, it contains a lot of the material, maybe a water content also sometimes along with the bedrock, maybe a shale of rock or maybe a rock chips along with a hard rock or weathered rocks, things like that. Now we'll go to the moisture equilibrium in the soil. The soil moisture equilibrium it develops because of the properties, some are chemical, some are organic materials, or some are this physics, some are chemistry. The cohesion, addition, surface tension, capillary actions. The addition, surface tension, capillary actions are physics of the moisture. Cohesion and bonding under attractions are chemistry of the water content or the moisture content. The question what this means is the attraction of the water to itself by hydrogen bonds. Addition is the attraction of water to other surface and substances. Surface tension is an interaction between the hydrogen bonding and Earth gravitational pull. Capillary action is a physics. It's a wettable surface causes a film of water to partially pull away from other water molecules and clinging onto the third surface or whatever the surface available, you call it as the capillary action. Capillary action is very important in soil and plant water relations because that contribute mainly to the moisture equilibrium in the soil. So relevant to each one, that's a cohesion, that's a capillary rise, and this is a surface tension, and this is your addition. So because of cohesion, whatever the disturbance coming to the water, it stays together. And whatever the disturbance given by the third material, maybe if you drag a knife along with that water sticking and going up is pertaining to the additional character. When you just float a steel pin, then along with the water, it stays on the top surface of the water because of surface tension, though the density of the steel is higher than water and it doesn't follow the principles of laws of flotation. It floats because of the surface tension. Capillary action is the attraction of the neighboring surface. Suppose the water is attracted by the neighboring surface, the capillary raises will increase. And when the mass of the water increases to certain level and there is a balance arrive in between the capillary surface tension as well as mass of water. So when wider the pores, then the less will be the depth of the water what it seeps into it or sucks into it. When the suction is narrower, surface tension will be more powerful, so water rises at more height. That is the principles of capillary action. Now, equilibrium moisture content of sand, soil, and building materials. Now, moisture content of other materials we are seeing now. Materials such as stone, sand, ceramics are considered dry and have much lower equilibrium moisture content than organic materials. Soil moisture characters curves, moisture attraction curves. There are different plots you can have it between the moisture content and as well as the pores of the soil. What is the type of soil with respect to moisture? Soil moisture characteristic curve is more strongly affected by soil texture. As I said, because of the soil pores in that, the moisture content will be varying and the soil texture mostly contributing onto the capillary rise of the water in the soil. The moisture equilibrium results like this. When the water goes inside, some of the water sometimes is not allowed to rise inside the moisture because of the trapped air in the mass or the medium. Then the water absorption will be less. Or the entrapped air could not escape, then the water may not be able to enter. So uptake of water will be restricted. When cohesion is there, it can enter into that and because of attraction, it can go inside because water to water, it can stick. Then the evaporation. When the water reaches the top surface of the media, some of the moisture content it loses it. So it is also a status of equilibrium where the suction of the moisture from the bottom and loose out by evaporation is also reaches an equilibrium. So uptake of the water because of capillary, there is an equilibrium. There is because of addition, there is an equilibrium. Because of cohesion, there is an equilibrium. And there is evaporation. Because of that, the moisture equilibrium exists in the soil. So if you draw a graph, the water content for clayey soil, because pores are very small, its moisture content will be very high when compared to the sandy soil where the moisture it cannot retain because of the very large capillary sizes. So that is the character of the moisture content of the sandy soil and moisture equilibrium of the soil. So it is said, on the other hand, the volume intermediate sizes pores is likely to be relatively greater in compact soil, while the inner aggregate micropores remains unaffected. Hence, curves for the compact and uncompacted soil may be nearly identical at a high suction rate. At very high suction range, water is held primarily by adsorption and hence retention in texture than a structural attribute of the soil. So structure is very important for the moisture equilibrium. Now, coming back to the soil structure, if you take a piece of the soil, then it has, as I said, there are compacted materials at the bottom, maybe a weathered rock, maybe a solid rock, or maybe a igneous rock, or maybe a rock which is from the molten lava, things like that. Upon that, you can have the weathered rock because it has been exposed for a longer time in the millions of years back. Then you have the well-settled soil is the B, where in the well-settled soil, soil can or the vegetations can also have their roots embedded on that. Then you have maybe around less than 10 feet, you have the moderately settled soil, and less than 2 feet, you have the loose soil on which you have the vegetations. This you call it as a soil pedum, and that is a ground structure of the soil. Now, what are the major components of the soil? Mineral matter, then organic matter, then air, entrapped air, water. This water only contribute to the moisture content in the soil, which we are talking about the moisture equilibrium of the soil. But as such, the major component of the soil is contributed to by various other materials like this. So if you look at it, so the pore space is 50% in any components of the soil. There are four components of the soil, as I said earlier. There is a mineral matter which contribute 45% in the soil. Water maybe 25%, air, entrapped air is 25%. Organic matter contribute to the minimal of 5%. So the solid, mineral and organic is 50%, water and air occupied in the soil is another 50%. This is the component of the soil, and these are all the basic component of the soil. And only the four types of the soil contribute to the soil. Then three fractions of mineral matters are sand, silt, clay. Sand, silt, and clay, they are all the basic component in the solid materials. So sand, if you look at it, it's a very large in size when compared to silt and clay. Silt and clay is a very smaller times, maybe less than 100 or 1000 or 1 million. Clay is a very small particles, maybe at the stage of colloidal level sometime. Some of the clay particles will have the colloidal sizes also because they are attracted by the surface of the clay surface materials. And further, if you look at it, the soil texture, the gravel is very big in size, maybe around up to 2 millimeter in size. Sand may be 1 millimeter in size between one point to another point. That is, the 3 is marked on 1 millimeter on either side. Silt is just a dot. That is means what? It is about a millimeter. It's less. It is about 1/100th of a millimeter. Clay is invisible at this scale because it runs in micron. As I said, clay is in the status of colloidal level also sometimes. So sand is maybe greater than 2 millimeter, and your silt is between 0.05 mm to 2 mm, and clay is less than 0.05 mm. Or then you have to measure it in terms of microns. That is the status quo of the soil sizes, and all this comprises of soil texture. So you can have the textural triangle. For example, you can have a sand and then silt variations. Sand start with 100, full of material is 100% is sand, then that is at the leftmost corner. When the grade size reduces, it becomes silt, then on the right side you get a silt material. Now, this silt is again divided into silt and then clay. So, most of the material which is below the red line, the slashed red line, is called silt because it is less than 30% and percentage of silt here is 10%. Then percentage of clay on the other axis, if you see, then it goes on reduces and percentage of clay is 100% at the top, and that inclined large red line shows the percentage of the clay presence. So the percentage of clay is very high when it is at 100% above the red line. So that's called the textural triangle, and it is by USDA is the geological classification of the soils. Example of soil structure. So granular soil, so far we were talking about the size. Now you are talking about the characteristics of the soil. The granular. Granular means angular soil, which are all maybe of episode natures. Sometimes they are flaky and platy nature. So flat components are also there. Sometimes they are sharp edges called wedges. So there are the three types of the granular, platy, and wedges. Then blocky soils are subangular. The angular soils, when it get weathered or being disturbed by water or air, the sharp angle it loses, it becomes subangular. Angular material is very sharp angle as it is seen on the right side on the blocky material. They are very sharp angles sometimes where if you work on such angular material, it can spoil any of the soft material because it can cut like a very abrasive materials. So prismatic, some are very large materials like columnar material are called as prismatic. So columnar material sometimes may be angular because of sharp corners, sometimes may be a weathered prismatic material where it may be a columnar and then subangular materials. So these are all the 7 basic soil structure. One is the granular, another is a platy, another is a wedge, and blocky, another subangular, angular, columnar, and prismatic. This is the classification of 7 basic soil structure. Now, aspects of soil structures. The arrangement into the aggregates of the desirable shape and then size. So sometimes the aggregates, the arrangements into the aggregates are called the one of the soil structure aspect. The other aspect is the stability of the aggregate. Aggregate is a larger size or all put together in a single form. The stability of the aggregate. The configuration of the pores, how the pores are being located in an aggregate or in a mass of the soil. Factors that affect aggregate and then stability. The factors that very much affect the aggregate and stability are a kind of clay. What is the type of clay? A clay can contain very small materials, maybe a flaky nature or an angular material or maybe a colloidal nature. Then the stability of the soil mass because of the clayey nature is very much affected because of the presence of the water content in the clay. Because clay can retain large amount of water. Because of that, the behavior of the soil itself is very unexpected or very wrongly you will predict it. Chemical elements associated with the clay. Some of the chemical elements which are associated with clay can cause us the swelling of the clay as well as the shrinkage of the clay. Some of the minerals, because of the water content, can evaporate. Some of the elements will be very corrosive and chemical effects will be very serious in the stability of the clay, in the stability of the soil. So chemical element associated with the clay is also to be considered when you want to see the stability of the aggregate of the mass. So this will affect seriously, and that is one of the factor in the stability, aggregate stability. So kind of clay is one thing, the chemical element associated with the clay is another thing. So these are all comes under the soil structure. So let us go for the another area. The nature of the product of the decomposition of the organic matter. The nature of the product of the decomposition of the organic matter. That is, sometimes the soil can contain the roots of the vegetations, or sometimes the decaying material may be a rubber, or some of the waste material which can possibly can decay also. Maybe a timber material or cut off a timber, or a decayed rubber, or a decayed paper, or a cardboard, or maybe a processed material which can decay for a longer time. Then the nature of the product decomposition of organic matter can cause the stability of the aggregate. How it causes means when it's being entrapped in the soil, this organic matter decay and reduces in its volume. Because when it is entrapped inside the soil, the reduced volume will be occupying a lesser volume inside the soil. When it occupying the lesser volume inside the soil, air from the outside moisture enter there and air will be locked up in that organic matters. In such cases, locking of the air will be enormous in the soil, and because of that, the soil compressibility and stability of the soil is very much affected because of the entrapped air, which is because of the decomposition of the organic matter and nature of the product. Hence, the aggregate stability is because of the kind of the clay, chemical element associated with the clay, nature of the product of the decomposition of the organic matter. These are all contributing to the soil structure. The nature of microbial populations. Microbial population means because of the decay, there are a lot of microorganisms are being developed under the air. These organisms sometimes may be killed by the chemical element associated with the clay, or sometimes it may be digested by the sand particles, and they will be micro digestions. The digested particle will be less voluminous, or maybe a less solid when compared to the solid mineral materials. Then the compressibility of the soil will be very much affected because of the microbial populations, because they consume the minerals and other materials in the soil, and they digest it, and the digested part of the material will be occupying lesser volume, or it can be a decaying part of it. So microbial populations will very much affect the soil structure and aggregate stability of the soil. These are all very important when we deal with the structure of the soil. Factors that affect the soil structure now. The kind of clay. Now we said a clay. Now clay has a lot of varieties are there. There are alluvial clay. The clay particles may be a peat or a black cotton, or different clay are there. Maybe a flaky type of clay, maybe an angular type of clay, as I said, maybe a mineral type of, maybe a decaying type of. So they will affect the soil structure as in the case of the previous explanations. So soil structure affect the because of the kind of the clay, what type of the clay. Because some clay will be flow like a water when the moisture content increases, or suppose the liquid limit, and then the other limits are being very low for the clay, so it will flow like the water, and the stability of the soil is very much affected because of the kind of the clay. Then amount of the organic matter. So as we said, organic matter will affect, but amount of the organic matter is very large. Then the stability of factor for the soil structure is very poor. That's why if you look at maybe some places, the low-lying areas are being filled with the garbages where the organic and inorganic materials will be very high. If somebody want to construct any building, that organic part of the decayed part of the soil should not be considered for any bearing capacity factors. So the soil which are being contained by the amount of organic matter should be ignored or removed, or it should be, you should reach the foundation crossing the organic matter of the soil. So soil structure is very much affected. Your foundation is very much affected because of the organic matters. So soil structure is very important to understand when you really want to design the foundation part of it. Freezing and thawing. What is freezing and thawing? Freezing means whatever the water entrapped into the moisture of the soil, it get freezed up. When it becomes freezed up, it's a solid. The solid water is slightly higher in volume when compared to when it is in the liquid state, because the liquid state can occupy any part of the volume in that, because of the flowing nature is there. But when it freezes, it becomes solid. It cannot accommodate any flow character of the material. So it in its own place, it increases the volume and making the cracks on the soil mass. That's why in the drought area, uh, the maybe in the icing countries where the land, where the moisture will be entrapped into the soil, when it get freezes, then it disturbs the soil very badly. Unthawing means then it will affect the top surface, and cracking of the surface is also possible, because that is called freezing and thawing. Wetting and drying. This is typically what we call it as weathering. Wetting means when some particles are being wetted, then the organic matter, mineral matters, all those things sometimes may be in the status of liquid. When it gets dried, then the liquid particles, when it evaporates, it take away the mineral along with that and evaporate in the moisture. It occupies a lesser volume, or the whatever the material left out may be less in its mineral, or the mineral what's the original mineral will not be present in that. That's a form of a decay. So wetting and drying is a way of a decaying of the material, or maybe weathering of the material. So the top material will loses its strength because of the wetting and drying, and that is one of the important factor of the soil structure which affect wetting and drying. Then action of burrowing organisms. Some organisms dig a pit under that and spoil the earth, and because of that soil structure is very badly affected. So borrowing, removing some material and throwing in some other place, and organisms will be developing each own uh, living places where lot of things have been decayed there, or the volume will be reduces after burrowing. So the organisms spoil the mass, and soil structure is very much affected. There may be underneath, if you see, maybe in the seawater, lot of the fisheries, or maybe lot of the sea animals will spoil the organisms. Sometimes they convert the rock into some of the other materials like corals and other things. So burrowing organisms that can happen even on the surfaces also. Maybe some of them are decayed, or some of them are because of the, for example, the root is being penetrated into the soil mass. Then after some time when the tree dies down, then the organic matter which is buried inside the root gets decayed, and which causes the spoiling of the soil structure. Growth of root systems of the plant was what I just explained now, the burrowing because of the organisms, and the same action is applicable for the vegetations of the root systems and plants. One important note we should note here is in the soil structure is all of these have the loosening effect on the soil, but they have no effect on aggregate stability. So even though it loses and soil gets loses the soil, but the stability may be there, but other properties like compressibility, moisture content things, other structure may be affected. So that's how the soil stays in its place for a longer time. Then other properties like bulk density is the determination by dividing the weight of the woven dry soil in the gram by its volumetric in cubic centimeter. Why it is given here is the bulk density will define the character of the soil. whether the dense soil or maybe a loose soil or maybe a character of the soil, whatever it is. So normally it is characterized. So bulk density is one of the important factor in the soil parameters. The variation in the bulk density is due largely to difference in the total pore space. Yes, as I said, bulk density is maybe very high, then the pore space will be very less. When the bulk density is very well, bulk density is occupied by the pore space of the water, then the pore water pressure will be there, then the solid mass will be less in that. So the solid mass is more when there is no moisture. So total pores is more and more, and water content is low. So normally we do it when we design the footing also. Gamma minus 1 we used to take as the density of the soil, because minus 1 is the water content when the water table raised to the ground level. So the variation in the bulk density is due to largely to the difference in the total pore space and the water occupancies. Soil color. Soil color is very much affected because of the minerals and other things present in the soil. Indicator of the different soil types. Indicator of the certain physical and chemical characteristics. Due to humus content and chemical nature of the iron compound present in the soil, soil color varies. So the ferrous oxide gives a gray color on the soil. Ferric oxide Fe2O2 gives a red earth or the red soil. Hydrated ferric oxide 2FeO2 3H2O is an yellowish color. So these are all the chemical formula for the various form of the material present in the soil. So the soil color and textures are very important to understand. The major form of the iron and effect of the soil color is given in the table. Ferrous oxide gray, ferric oxide red, and hydrated ferric oxide is yellow. Now soil structure is the way in which the individual particles are arranged into a large distinct aggregate. So this is a conclusion soil. Soil aggregates are group of soil particles that bind together more strongly than to the neighboring particle. It's a soil aggregate mass. Aggregate stability refers to the ability of the soil aggregate to avoid disintegration when disturbances by the tillage or the erosion. Bulk density is the indicator of the soil compaction and is calculated by the dry weight of the soil divided by its volume. The variation of the bulk density is due largely to the difference in total pore space. Factors that affect aggregate is the amount of clay, chemical element, organic matter, biological activity. Soil structure is affected because of the organic matter, soil organisms, tillage, freezing and thawing, and water. So this is a compact information about the lecture, whatever I presented so far. So soil structure, the differential between soil structure and aggregate is the totality of keeping the soil, and soil structure is the presence of other materials in the soil. But both will have the overlapping. So that is the most of the points we covered in soil structure interactions and moisture equilibrium. Soil color is a human content indicator of the different soil types, and iron compound in the soil is the major indicator for the soil color. Certain physical and chemical characters due to humus content and chemical nature of the iron compound. These are all given by the various authors when we collect the materials. So with that, we will be coming down to the closing session, and I thank for the audience. I thank one and all for you for showing an attention towards my lecture. And thanks once again for your presence here. Thank you.